So today we're talking about pH of bases. We already know how to do pH of acids, back and forth. Now we're going to learn how to do it for bases. So let's remember something about the pH scale. The pH scale has our acid range, it has a base range, it has a neutral in the middle. And more importantly for right now, that's not a very nice arrow, is that the pH number corresponds to or connects to a concentration of hydronium. And that fact is true mathematically anyhow, even if I'm talking about bases. So you'll see that as my pH numbers go all the way to up high, my concentrations of hydronium ion keep getting smaller and smaller and smaller. The problem is that's not helpful. Well, let's remind ourselves of a couple of other things. Acids, they're about hydronium or hydrogen ion, which are because they're equivalent. And I can get either the hydronium or the hydrogen ion either through dissociation or ionization. It's equivalent in water. We don't really worry too much about the difference. And then pH is the negative log of the concentration of hydronium or hydrogen. And if I know the pH and I want the concentration, then I use that pH value as a negative exponent on 10. What do we do for bases? Well, actually, we're going to do the same kind of thing, but we have to remember a couple of key differences. One, that for bases, we're talking about hydroxide ion, which unfortunately sounds a lot alike, hydroxide, hydronium. We need to keep them straight because if we get them mixed up, we're going to end up in a mess. We can get hydronium from an acid. We get hydroxide from a base. Nice recovery, hey? And the dissociation of a base. But if I know something about hydroxide in a base, how do I get a pH number? And if I have a pH number that's a basic one, how do I learn about hydroxide ion concentration? Well, stay tuned. We're going to use the POH scale. Now, it's not really eccentric and it's not really a cousin, but it is something that's kind of unusual for most people. Most people know about pH. And they know about the acid and the base and the neutral range. And they know kind of what those numbers tell us. Very few people have heard about the POH scale. In fact, only chemistry students have heard about the POH scale. Because we never use the POH scale all by itself. We use it to get us to pH. It's a middle thing. And the key thing about the POH scale is this relationship on the bottom. pH plus POH add up to 14. All the time. So what does P mean? It's going to be for us treated as an operation. So it means negative log of something. So if I'm doing the pH, that means P means a negative log of H, really, the concentration of H. So it's the negative logarithm of the molarity, concentration of hydrogen. pH is about H. It's the negative log of H. So then POH is the negative log of the OH. That's it. That's all there is to it. And we can put it in words, but same thing. It means all the same stuff. So how do I calculate the POH? Well, I just saw it back there a minute ago. It's the negative log of this concentration. So grab a calculator, find the negative log of 0.001. Well, we did this when we were doing pH. But now it's hydroxide ion. But it's the same number. Your calculator won't know the difference whether it's hydroxide or hydronium. That's your job. But the negative log of 0.001 is 3. Since it's a hydroxide ion concentration, it's POH. Well, what if I had a solution that was 10 times more concentrated? Turns out, same pattern exists. So every step of 1 on the POH scale is a 10 times difference in concentration. What if the concentration was 0.025? POH is 1.6. And I'll give you this one to try. Hopefully you have an answer. Here it is if you don't, or if you do, to check. And one last one, please do it quick. And POH is 4.1. But, like I said, we don't use POH all by itself. We use to find pH. And this is how we find pH. 14 minus the POH. So let's take those POH values we had and use them to calculate pH. So 14 minus 3, pH is 11. POH is 2. 14 minus 2, pH is 12. And if it's 1.6, pH is 12.4. And we continue, and we continue, and we have calculated the pH for all those bases that we had in the previous slide. Okay, I have a base. I want the pH. Just did it. How did we do it? We first found the pOH, negative log hydroxide. Then I did 14 subtract that number. So here's one for you to try. If the solution is decimal 0.035 mole per liter hydroxide, and you'll sometimes see instead of hydroxide, you'll sometimes get the formula of a strong base instead of hydroxide. Either way, we're going to be doing the same thing. You're going to first calculate the pOH, and then you calculate the pH. Now, quick little aside, because we never report all by itself the pOH, if you don't show me this, that's okay. You'll still get full marks. And because of that, usually the question will say, it'll be the same number of marks whether it's the pH of an acid or the pH of a base, because I need you to know whether or not it's an acid or base. I don't want to give you any kind of clues or hints in the question, so you got to know your chemistry. All right, well, what if I know the pH, or pOH rather? If I know the pOH, well, what if I knew the pH? Well, okay, if I know the pOH, then this was my rule for acids, and I have the same rule for bases. If the pOH is 2.8, then the hydroxide ion concentration is use that number as an exponent, negative exponent on 10. And you'll notice the numbers are the same because your calculator doesn't know if it's an acid or a base. You have to. So it's more likely we know the the pH of a base. We've dipped it, we've tested it, you've been told, somehow or another you know the pH, and the pH happens to be a base. You're going to first calculate the pOH, because pH is about hydrogen. I could just circle that one. pH is about hydrogen. Hydrogen ion, hydronium ion, it's about hydrogen. I need to turn that into hydroxide. Once I calculate the pOH, then I use that pOH number as a negative exponent on 10. So here's one to try. Concentration of hydroxide ion. If the pH is 11.6, clearly a basic pH. So my job 1 is turn that into pOH. Right there. Job 2, use that as a negative exponent, and I get concentration of hydroxide ion. Give you some to try. Okay, you're going to give you several pHs and, several concentrations to calculate the pH of, 2 steps. And I'm also going to give you several pHs to calculate the concentration of hydroxide for. Now, pause this to write it down if you need to. I'm going to move on to the next thing in a couple of seconds. What I want you to look at on the next thing is it's a bit of a plan, a bit of a schematic, something like that. Let's jump to it so you can see it. If I know the concentration of hydronium and I want to find the pH, I'm going to follow the arrow along the top and do this. The pH is the negative log of the hydronium ion concentration. If I know the pH and I want to know the concentration, I follow the arrow on the bottom and I use pH as a negative exponent. If I know hydroxide and I want to find pH, I have to follow this arrow along the top and do this. That gets me to here. Then I go up here using that. Now I didn't make this one too fancy. This is the relationship whether I'm doing pH is 14 minus pOH or the other way around, pOH is 14 minus pH. I'm solving this relationship. If I know the pH and I'm trying to get here, there's no way to go directly. I have to first go to pOH and then go to here. So I find this thing kind of helpful. You might not. One way or another, you have to keep straight in your head when you do one step to the left, to the right, when you do one step to the left, when you do step, and going one way when you do step going the other way. Okay. Anyhow, we'll talk about this in class. We're going to use pH and pOH calculations a lot, but we're going to add to it very, very quickly. So make sure that you can do these quite easily, let's say fluently, and I can throw any question I want at you, and you can just start writing it out. Anyhow, talk to you later in class. See ya.